You've probably heard that phrase, right? 6 degrees of separation. The idea that you're just a few handshakes away from, well, pretty much anyone on Earth. A pop star, the president, you name it. And yeah, it sounds like a fun little party game, but what if it's more than that? What if it's actually a fundamental law of our hyper-connected world? Let's dive in, because the science behind this is, I promise you, way more surprising and way more important than you might think.
So, to make this real, let's start with this story. Back in 1999, a German newspaper decided to put this whole theory to the test. They went to a falafel salesman named Salah Bengali and asked him, who in the entire world would you most like to meet? His answer? His favorite actor, the legend himself, Marlon Brando. I mean, think about that connection. A guy selling falafel in Germany and a huge movie star in Hollywood. It seems impossible, right? Well, they set out to find the chain.
And the result is what makes this whole thing so fascinating. It only took 6 steps. 6 people who knew each other on a first-name basis. A friend who knew a coworker, who knew his girlfriend, who knew a sorority sister. And boom, just like that, you're at Marlon Brando. So this gets you thinking, was this just a wild, lucky fluke, or does it actually reveal something really deep about the very structure of our society?
And that right there is the central paradox. We live in a world with 8 billion people. I mean, it's unimaginably vast. And yet stories like that make it feel incredibly small, almost intimate. So how can both of those things be true at the same time? To figure this out, we need to look at 2 totally different ways our world could be wired up.
Okay, so just imagine 2 possibilities. First, you've got the random world, where let's say your 100 closest friends are just sprinkled completely at random across the entire planet. Then you have the clustered world, which, feels a lot more realistic. Most of your friends live kind of near you, and a lot of them are probably friends with each other. Our world feels like the clustered one, for sure.
Now, if the world were random, the math is actually super simple. If you have 100 friends, and each of them has 100 friends you don't know, you can suddenly reach 10,000 people. And their friends, that's 1,000,000. The number just explodes. You do that 5 times, and you've reached more people than are on the entire planet. So, mystery solved, if our world were random. But we know it isn't.
And here's where the paradox really hits you. If you model a purely clustered world, where you only know your neighbors and they only know theirs, getting a message to someone on the other side of the planet would take, on average, a staggering 40 million steps. Not 6, 40 million. So how is it possible that our world is so clearly clustered, but it acts like it's random? So in the mid-90s, 2 mathematicians, Duncan Watts and Steve Strogatz, decided they were going to crack this thing. They knew the world wasn't perfectly ordered, but it wasn't perfectly random either. They figured the answer had to be hiding somewhere in that vast middle ground between the 2 extremes. And their idea was it was pure genius. They built a computer model of a perfectly ordered, clustered network where everyone only knew their neighbors. Then they started to turn a randomness knob, just like Strogatz said. They took a tiny fraction of those local connections and rewired them to link to completely random, distant parts of the network. They basically created a few shortcuts.
And this was the big reveal, the aha moment. As soon as they rewired just 1% of the links, the average number of steps needed to connect any 2 points, what they call the path length, it just plummeted. The world became small, just like that. But, and this is the amazing part, the network stayed highly clustered. You could have both at the same time. All you need are a few of those random long-distance connections.
This lines up perfectly with a famous idea from sociology called the strength of weak ties. Think about it. When you're looking for a job, is it usually your best friend who helps you out? Or is it that acquaintance you met at a party once? A lot of the time, it's the acquaintance. They are your shortcut to a totally different social circle. Those are the connections that make our big world feel so small. But of course, just as that mystery got solved, a brand new one popped up. A physicist named Albert Laszlo Barabasi started mapping the early World Wide Web, and he found that, yeah, it was a small world for sure, but it didn't really look like the model Watts and Strogatz had built. It wasn't just random shortcuts shrinking the world. There was something else going on. See, Barabasi was expecting to find a bell curve, most websites having a kind of average number of links pointing to them. But what he found was totally different. It turned out most sites had very few links, but a tiny number of sites, like Yahoo back in the day, had thousands and thousands of links. They were these massive hubs, these superconnectors holding the whole network together.
So how do you get these hubs? Barabasi came up with this beautifully simple mechanism he called preferential attachment, and really, it's just a rich get richer effect.
When you create a new web page, you're much more likely to link to a site that's already popular and well-known, right? Like Google or Wikipedia. And that just makes those popular sites, those hubs, even bigger and more connected.
So it all just boils down to two really simple rules. First, the network is always growing. New websites, new people, new whatever. And second, there's a built-in bias to connect to what's already popular. You put those two things together, and hubs don't just happen by chance, their emergence is pretty much inevitable.
And what's absolutely amazing is that once you see this pattern, you start to see it everywhere. It's this universal structure. In transportation, you've got airport hubs like Chicago O'Hare. In our own cells, the ATP molecule is a metabolic hub. In nature, keystone species are hubs. Even in our brains. It's just a fundamental way that complex systems organize themselves.
Okay, so we've figured out how our world is structured. It's this mix of clusters, shortcuts, and hubs. But the big question is, so what? What does it actually mean to live in a world that's wired up like this? Well, it turns out that this incredible connectivity is a really powerful double-edged sword.
So for instance, having a small world is fantastic for spreading good ideas and useful information really, really fast. But that exact same efficiency also makes it fantastic for spreading viruses and, misinformation. And hubs? They make networks incredibly efficient, but they also create a huge vulnerability. You take out a major airport hub with a snowstorm, and the entire system can just grind to a halt.
And here is a powerful, real-world example of why all this matters so much. In the early 90s, Thailand was struggling with a rapidly spreading HIV epidemic. And the usual playbook, posters, TV ads aimed at the general public, it just wasn't working. The infections just kept rising. So the government switched up its strategy. Instead of trying to talk to everyone, they focused on the hubs of the transmission network, the country's brothels. By enforcing a very strict 100% condom policy in those specific places, the results were just astounding. They prevented an estimated 5 million infections. Understanding the network's structure literally saved millions of lives.
But the influence of these networks goes even deeper. It's not just about how things spread through the network. The very shape of the network itself can actually influence our behavior, like our willingness to cooperate with each other, often without us even realizing it. So to test this, some researchers use the famous prisoner's dilemma game, and the logic is pretty simple. No matter what the other person does, you are always personally better off if you defect or betray them. But if you both defect, you both end up with a terrible outcome when you could have both just cooperated and done pretty well. Now here's where it gets really interesting. They had people play this game on a network, and in a highly clustered world, a small group of nice, cooperative people could actually survive and spread their niceness. But then they made one tiny change. They added just a few of those random shortcuts, turning it into a small world. The result? It was shocking. The exact same cooperators got crushed, and the network totally collapsed into a world of selfish defectors. The structure of the connections alone determined whether people were nice or nasty.
I mean, that's a pretty chilling thought, isn't it? If just tweaking the wiring a little bit can turn a cooperative society into a mean one, does that mean we're all just puppets of whatever network we happen to be in? Are we totally at the mercy of its structure?
But here's the final, and I think most empowering part of the story. In a follow-up experiment, the researchers gave the players one new ability: the power to choose who they were connected to. And when people could actively cut their ties with the defectors and form new ones with the cooperators, cooperation won. It triumphed, no matter what the network started out looking like. So yeah, our networks have this powerful, invisible influence on us. But we, in turn, have the power to shape them. The crucial takeaway is we have more agency than we think.